Hey guys, Mr. Milton here. Today we're going to look at finding the areas of trapezoids, rhombuses, and kites. At the end of this video you should be able to find the areas of those figures. Okay, let's start into it, and I'm going to tell you the formula for areas of a trapezoid, and then I'll show you why we can come to that conclusion. At least one of the ways that we can come to that conclusion. Okay, the area of a trapezoid is always going to be 1/2 base 1 plus base 2 times height. And this is why. If you take two trapezoids based off of what they are, have two parallel sides, one pair of parallel sides. If you take two trapezoids and you put them together, you can see in this diagram here, it's sort of like a parallelogram. Okay, now obviously we'd have two of them, and so in order to get the area of one of the trapezoids, we'd have to divide by 1/2. Okay, a parallelogram is its base times its height. We add them together, we have one base and two bases, so one of the sides would be base 1 plus base 2 times its perpendicular height. Okay, the important part here is that the height is always perpendicular to the bases. Okay, alright, and so we need to make sure that we have that as we're finding the area. Let's go through a couple of these together. Okay, it says find the area of each of the trapezoids below, leave the answer in simplest radical form. Okay, remember that what we can do, in this formula, area is 1/2 base 1, which doesn't matter what you call base 1, I'll call this base 1 20, plus base 2 25, times the height, perpendicular height is 15. Okay, perpendicular gives us this as a right angle. So, use my calculator here, 1/2 45 times 15. And that gives me 337.5 centimeters squared. Okay, in this case, I know it says simplest radical form, but we didn't have to do anything to find another thing, so there's no radicals that came up. Okay, guess I should have given you more space to see. Alright, number 2, we're finding the area. Again, is going to be 1/2 base 1, which is 5, plus base 2, which is 7. Now times height. Now here we don't have the height, but they did give us that this angle is 60. So what I'm going to do is I'm going to draw in where my height would be. This is 90, this would be 30. Okay, now notice that we have a 30, 60, 90 triangle. Again, it's going to be helpful if you don't remember these triangles to take some time to study those. Remember in a 30, 60, 90 triangle that this side is S, the hypotenuse will be 2S, sorry, and the long side will be S radical 3. So, now we're going to use some reasoning. Since this is 5 and this is 7, they're parallel, so I can just cut this off with a straight line. I know that this will be 2, right? Because 5 minus 7, or 7 minus 5 is 2. So that means that our height will be S radical 3, or 2 radical 3. So there we have it, 2 radical 3. Alright, and now the rest of this is just multiplying 1/2 12 times 2 radical 3, which is 6 times 2 radical 3, which is 12 radical 3. Meters squared. So 12 radical 3 meters squared. Alright, let's look at number 3 together. Number 3, we have 8 here. 8 is going to be our height. We have this as 5. Now, what's going to be important for us in this problem is finding out the second base, because if we start off 1/2 base 1, which is 5, times, we don't know base 2 yet, but we do know our height is 8. So we need to find this out. Alright, and this is how we'll do it. We already know that this is 8. We already know that this is 5. We need to know these two pieces. Okay. We have this as 8, just because we can see that these are the same heights. This is 5. And what they told us here, and if you didn't notice this, is our arcs that are telling us that these two angles are the same. Okay, so I'm going to start down here because that helps me out. I see a special right triangle. I know this has to be 90. I have a right angle where two angles are the same, and so that makes this a 45, 45, 90 triangle. Okay, because of that, I know that these two sides are going to be the same. So this is 8. No, it doesn't look the same, but I can tell that it's going to be the same. Maybe I should write 8 like this because I'm sitting like this. Okay. Alright, now in this other triangle, I don't have anything that tells me, hey, this is a special triangle or anything like that. And so what I'm going to do is I'm going to say I know it's a right triangle, and I'm going to use that to find out what this side is. So 10 squared equals 8 squared plus, let's call this x squared. So 100 equals 64 plus x squared. Subtract, that's 36. X squared equals 36, so x will be 6. So this side is 6. And so now I know my second base. 6 plus 5 plus 8 is 19. So area equals 1/2 19 times its height 8. And that should give me 76. 76 feet squared. Make sure none of my math was wrong. 4 times 19, 76. Cool. Alright, finally, for this trapezoids, I have a right angle here. I'm going to give you this angle. I'm going to let you figure out the rest of this after we do that. Okay. Notice here we have a right angle. We can tell because this is 90. These two are supplementary. They make a straight line. This is 2x. This is x. So there is 90 left in this triangle. We have 3x. So since 3x equals 90, we know that x will equal 30. Now that's going to be important for us because now we see this is a 30, 60, 90 triangle. Okay. Since this is a 30, 60, 90 triangle, we'll use that to find this other base. Remember our equation. 1/2 base 1 plus base 2 times height. Okay. Use that to find our second base because our second base is y, let's say, and our height will be here. Okay, I'm going to call it z. Okay, so use that to find your area. Okay, bring that into class completed. Flip it to the back side. Let's talk about the areas of rhombuses and kites. Alright, remember that these are not necessarily that you need a formula to do, but the formulas do make it easier. I know I asked you to find areas of rhombuses and kites a couple chapters ago. And we found those a couple chapters ago just by finding the area of each of the triangles. The formula for areas of rhombuses and kites is that the area is going to be 1/2 diagonal 1 times diagonal 2. Okay? And so this is why we can do that. Basically, and the same reasoning applies for kites and rhombuses. Basically what we did before is we just found the areas of triangles. And remember, the area of a triangle is base times height. 1/2 base times height. And so what we did, if we looked at this triangle, we have the base would be d2 and the height would be 1/2 of d1. Okay? And then we'd have to do the base be d2 and the height would be 1/2 of d1. Okay, and so what we did is instead of multiplying and finding each triangle by itself, what we said is, hey, we can do the same thing and just say diagonal 1 times diagonal 2, right? Diagonal 1 times diagonal 2, and then 1/2 of that is going to be the area of the triangles, basically. So now instead of doing area of this triangle, area of this triangle, area of this triangle, area of this triangle all separately, now we're doing it all together. Okay? Still, we'll have to use some Pythagorean theorem sometimes to find some missing sides, since we know that the diagonals of rhombuses and kites are perpendicular. Let's go and try that out. So number one, it tells us that AB is congruent to BC, which is congruent to CD, which is congruent to DA, and what they're telling us is, hey, this is a rhombus. Okay, that helps us because we know that this is 90 degrees now. And so now we'll use that because we know, first of all, that rhombuses, diagonals bisect each other, like all parallelograms. And so once we find this missing side, we can find the second diagonal. And we'll find that missing side. 15 squared will equal 12 squared plus, I don't know, x squared. 225 equals 144 plus x squared. So 225 minus 144 81. So x squared equals 81. That means x will be 9. So this is 9, and that's 9. And so now I can use the formula. Area equals 1/2 diagonal 1, which is 18, 9 plus 9, and diagonal 2, which is 24, 12 plus 12. And so 1/2 18 times 24, which would be 216. 216 meters squared. Okay, for a kite, again they told us this Km is perpendicular to NL. Okay, just tells us it's a kite, and it also tells us that these are our altitudes, so we can use that. So area equals 1/2 diagonal 1, which is 2 plus 5, 7. Diagonal 2, which is 3 plus 3, 6. So 3 times 7 is 21. 21 meters squared. Alright, number 3 is a little bit tricky, but let's, oh, sorry, did not know it was that crooked. 3 is a little bit tricky, but let's go for it. So, they tell us that the perimeter is 72. They're all the same, so I'm going to do 72 divided by 4 to find out what each of these sides are. They're all 18. Okay. They also tell us that these are all the same, so that means that this is a rhombus. So I know that our diagonals are perpendicular. This is 30 degrees, and this is 60 degrees. This is 18, right? And so we have a 30, 60, 90 triangle. Since our hypotenuse is 2s, across from our hypotenuse, across from our 30-degree angle is s. So it means this is 9. This will be 9. Okay, so s is 9. This will be s radical 3 or 9 radical 3. And so now I found my diagonals. So area of this rhombus will be 1/2 diagonal 1, 9 plus 9, 18, times diagonal 2, which is 9 radical 3 plus 9 radical 3, or 18 radical 3. So in my calculator, I'm going to know that I need to know 1/2 18 times 18 is 162 radical 3 centimeters squared. Okay. Alright, that's area of trapezoids, kites, and rhombuses. Know those formulas, but remember how to use those formulas and why they're there, okay? That'll help you retain that a little bit better. Alright, see ya.